based on multitask training. So we'll include those in the report.
So my name is Heidi, and I'm going to talk you through some of the dementia experiments that we've chosen to put under the umbrella of combinations. So this is combining different data sets, it's combining different types of features, and by now I'm sure you're aware that we have a lot of those. And it's combining different modalities. So Julius have already talked a little bit about this, and Camilla was going to give a few more slides about this. So on the dementia side of things, we wanted to, as you might remember Frank mentioning much earlier in the morning, look at sort of three main research questions, if you like. So how can we make better use of these sort of diverse pockets of data we have? How can we better use our features to kind of be able to handle conditions where the test or runtime conditions are very different from the conditions under which we can train our models? And also, as Fanny has just illustrated, we really need to be able to much better handle the kind of errors that are kind of introduced by the ASR. So there's a lot of very good results coming out using lexicosyntactic features, but they're problematic if you start having ASR results where word error rates of around 40% are good. So we need to do something about that. So I'm just going to give you a few baseline results first. So this one is quite straightforward classification using SVM. If I train and test in a matched condition, so with two main databases we have, CCC and Cookie, I get nice high classification results. But if I go sort of off diagonal, if you like, and do a mismatch kind of test, these classification results are really poor. So what we're really looking at is to be able to train a model that can use all of the data during training and can handle fairly reasonably things during test. Another baseline sort of result, just showing what we generally know, that it's useful to be able to combine different sets of complementary features. What I'm going to show a few results is what we can do if there are situations where at runtime we haven't got access to the sort of features we have access to during training. Can we still somehow make use of these features during training to boost the model? So first I'm going to give you this combination result, if you like. So this is combining two feature sets, the CCC and the cookie theft. People haven't really worked with the CC data before, and so this is quite novel. I just took the same sort of feature sets to start with, but generated for both of them two different feature sets by using feature selection. So there's 40 features for each, and you just kind of put them all together in a big matrix like this. Some of the features are preferred by both of the data, but in general it's a sort of big matrix and it's a little bit sparse. These are the results. So the joint feature space model is the model trained on both of these data sets, two different types of features. And the classification results are pretty good, so they're sort of high, 90, around 80, 90. I've split them out here for the test set for the CCC and for the cookie, but of course it can deal with both of them. In comparison, the baseline, the cookie baseline for the feature selection gives high results as well, 81, and for the CCC as well, very high. But what we must remember with those two models, if I were to present it with test data, which was kind of off the diagonal again, I would have very poor results. Then we spent quite a lot of time during the workshop looking at this multi-view learning TCCA, and we worked with Raman and some other people here to try and develop this. And this is really interesting idea. So the idea here is that you might, during training, have access to a couple of different sources of information, or views as it's called here, and you want to learn an embedding, which is representing the feature space, if you like, with the maximum correlation between these two. So this is an unsupervised method. And we've used it for a couple of different ways. So one of the ways is, for example, in a situation where you might have access to the sort of traditional acoustic lexicosyntactic features during training, but during runtime you might only have access to the acoustic features. And this could be the case, for example, if you're trying to develop a system for the home that you want to run on a really low power, small processing device. You might not be able to run a big quality system or parsing, etc. So this is a fairly real situation. I'm going to show you some of our initial results in a minute. Another way we try to use it is, can we somehow make use of the manual transcript during training? Of course, during testing, we will only have access to the ASR, but can we somehow boost the model? Going back to the combination of the features, in a situation where you only have access to acoustic features during training, during runtime, the baseline, of course, you can only use the acoustic features during training, and the performance is suitably poor. But using GCC, we have about a 5% increase, and that's quite promising. So we haven't done, this is a sort of optimized with a bit of a grid search over the PCA parameters and embedding, but this is a really interesting result. And likewise, for the situation where we use the manual transcript to kind of boost the training or the model during training, of course, if you use ASR transcript both at training and testing, the performance is pretty poor or worse. But we see again a sort of about 5% improvement in results, which is encouraging. What we would really like to do as well is to use TCCA for combining two different feature sets, possibly with, or two different data sets with possibly two different feature sets. The problem is that GCCA likes to have the same view, or the same instance, if you like, which for us is the same speakers, along the rows, if you like, of the matrix, and you might have different views of it. And the view 2 is sort of guiding this embedding learn. But what we really have, if we work with, for example, something like CCC and cookies, I would have different speakers that contribute to one database and other speakers to the other database. And how do we go about combining this? So the kind of idea that we're still working on is to initially transform these matrices. So let's assume that we have the same features extracting from both of them, and they would then become the rows, and the columns would be the kind of how these features present themselves, if you like, for the different speakers. So this is, I'm glad Sanjeev introduced in the beginning this idea of working on it for a few months or years, maybe. Okay, so I'll hand over to Camilla.